Hi, everyone. I'm Aaron Larson, executive editor of Power Magazine, and you're listening to the Power Podcast. On today's episode, I'm joined by Thomas Ringman, Director of Business Development with Siemens Energy, and Yuan Chi, a sales manager, and Andy Chang, a project manager with Siemens Energy. Gentlemen, thank you for joining me. I'd like to have each of you tell a little bit about yourself. So, Thomas, why don't you go first?
Thank you, Aaron. And my name is Thomas Ringman. I'm with Siemens Energy for nearly 20 years, working in various fields, engineering, project management, and now in business development and sales. And actually, the Samba 2 project brought me to Taiwan. So now I'm located in Taipei for 4 years. So thank you, Aaron.
And Yuan, why don't you tell a little bit about yourself and your background, please?
Yes, my name is Yuan. I am a local sales manager, so I'm stationed in Taiwan. This project Samba brought Thomas to Taiwan, and I was here welcoming Thomas when he arrived. I even booked the COVID quarantine hotel for him. So I'm here as the main contact window to customer and then to our headquarter representative. So the sales locally is my responsibility.
And last but not least, Andy, please tell a little bit about yourself.
Thank you, Aaron. My name is Andy Chen. So I'm the local project manager executing this Samba 2 project now. So when Thomas and Ewan signed the contract, basically they handed over the contract to me and told me good luck. So went through this entire from day one all the way till even now. The power plant is in commercial operation, like close contact with our customer every day. Discuss on any topic, any future opportunity as well. Yeah. So here, yeah. So I'm actually very glad and that Thomas is here, signed the contract, and I had the opportunity to finish this project. So.
All right. Thank you, gentlemen. And Thomas, I guess I'd like to start with you and talk a little bit about the Samba 2 project. Can you walk us through the design and engineering features of the plant?
Yes. So Samba 2 is a 2-on-1 multi-shaft configuration. So that means that 2 gas turbines and 2 HRSGs are serving one steam turbine in multi-shaft. So each gas turbine and steam turbine has its own generator. And we have used in this project our latest and biggest gas turbine, the SGT 9000 HL. And the steam turbine is SST 5000. So that's a triple pressure steam turbine with a combined HP and IP turbine and a dual flow LP turbine. So also we had an air-cooled condenser condensing the steam from that steam turbine. And we had a 3-pressure reheat HRSG, which was of Benson type technology, which we used. So mainly enabling a high water saving contribution. So I think this is the configuration and the plant attributes. And I think in summary, this enabled the plants to start up very fast with the gas turbine and the Benson type, and that suits for Taiwan requirements very well.
Thanks, Thomas. I should mention that the Samba 2 project was a Power Magazine 2025 Top Plant Award winner in the gas-fired power category. And I had the privilege of writing the article about the plant, which was featured in the October issue of Power. And while doing my research on the facility, one of the things that I found most interesting is how important efficiency is in Taiwan. Many people may not realize that Taiwan imports nearly all of the natural gas that it uses. And one of the key features of Siemens Energy's HL class is its efficiency, which exceeds 64% in combined cycle mode. Can you talk a little bit about the importance of efficiency, Thomas, and how it may have played a role in getting the Samba 2 project off the ground?
Yes, absolutely. So I think this was a key driver for our customer, Samba Power, behind. And this power plant right now is predominantly running on base load operation. So given that high grade of operation, along with a high gas price, so the efficiency of our turbines actually is a key contributor to an economic value of the customer. And that was one of the main features we were looking at, and that's why we were applying this new technology also to Samba.
Andy, what were some of the key challenges from your perspective in developing this project, and how did you overcome those?
Yeah, so like if we talk about project challenges, I can go on and on for many days. But of course, there's definitely some challenges in the project. So like, to build a power plant, to build this combined cycle power plant, everything looks great on paper, like to bring everything into life, and then that's in the entire different story, Yeah, it's like when we started the project, we're in the middle of a high peak of COVID period now. So like every project meeting, every design meeting, every coordination meeting were all done online now. So like you can imagine how much coordination, how much communication there were now in order to bring the team together, to be aligned on a certain topic, and to move forward. And then also we have our consortium partner CTCI, and this is a separate company, and we also need to bring the same understanding, again, same alignment to them with English as our basic language. CTCI, they're also based in Taiwan, so this is one of the first major challenges that we faced in the Samba 2 project. Like everything was done online, because nobody can travel, and then we just had to figure this out now. Yeah, and then for this project, we not only we had to line up big items, like the gas turbine and generator and stuff, but we also need to line up every, for example, every piping, every flanges, they need to be designed at to the right dimension, the right direction, so on-site construction people they can put this together. Yeah, that's the first challenge. Yeah, and then the second challenge is I would say during the COVID time and also post COVID time, there were problems with global sourcing now. Like because we're building this power plant, and not every single item that we can get it from the hardware store. Like everything is customized, big and customized, and then and also they're all coming from different part of the world, and internally in line, it's already hard enough. We also had to make sure that each of individual supplier they're doing the right thing. They're manufacturing the right product now. So they deliver to Taiwan, and we can build this together in the right manner, in the right schedule. So this was already tough. Yeah, and then I will say that when the parts are arriving on site, then we hit the manpower issue. Yeah, because also after COVID, when the war is open up again, so a lot of, I would say, the specialists, it's really hard to book them, and then we cannot build a power plant without those specialists. So this manpower was also a big issue. We had to talk to many people, to bring the right people at the right time to do the right job. Yeah, so this was I would say a big challenges that I will see for this project.
Thanks, Andy. And you did mention the collaboration with CTCI, which is a large EPC contractor in Taiwan. Ewan, maybe you can talk a little bit about how that played out, and maybe some of the other partners that you worked with in this project.
Yeah, so the collaboration is not only with our consortium partner, this CTCI EPC company, but actually with also the customer, Samba Power. We have everybody has the same target, is to bring power on grid as soon as possible. So with this same boat mentality, everybody sitting in the same boat and rolling towards the target actually helps the projects to be successful and to overcome any challenges. I think one example I remembered was on the day that we wanted to perform first fire. So very important milestone to start hot commissioning. And then I remember Thomas and I went to south of Taiwan. So this plant is in south of Taiwan. We were in Taipei. And then we were there since morning to show customer we are not only handing over to Andy and say good luck. We continue to care about this project, and then we continue to take care. Yeah. So and I remember we were there until evening after dinner. So there are many challenges to overcome to achieve it. And suddenly, I think everybody was working and hungry, and customer brought fried chicken as snack or desserts. And then I still remember not only on that night, and then for like continuously after that. So during the commissioning periods, customer were really taking care of the team, the consortium, the contractor. And I think this makes the contractor, the consortium, see that we have a customer who cares, who supports, and we don't want to disappoint. So I have to say, these projects were executed with a different priority. The priority is we solve problems, we proceed, and then I think nobody's really looking into the contract. We sit on the table, look at each other, and trying to find a resolution. So I think this mentality is really at the core. What made these projects? I think what Andy mentioned, this COVID labor shortage. There are other projects, power projects in Taiwan, under execution at the same time, and they didn't went so well or went so smooth. So this project was brought online on schedule, basically. So this is one of, I think, the results that evident or demonstrate this collaboration spirits between CDCI and Siemens Energy. And also, I think I have to give a big credit to our customers, Senba Power Co.
Yeah, I think those relationships go a long way to getting through any struggles that come up. And it sounds like you had a really good relationship with all of the parties that were involved. So, Andy, from your perspective, what lessons from this partnership could be applied to future energy infrastructure projects in the region, specifically in Taiwan?
Yeah. So like after this Senba Wind official dispatch, this is also one of the big milestones for customer Siemens Energy and our consortium partner CTCI. Immediately after that, the two core team from Siemens Energy and CTCI, we sit down and we talk about the next project, and which is currently executing at the moment. So we just started another project together with CDCI. So because we have this momentum and this mentality, from Senba to execution. Now each side they decided that they will keep their core team member from both sides, and they will continue to cherish this partnership with the next project now. So this is bringing a lot of benefit on the table. So like, because like each core members, they all remember all the little details, all the little problem they had in Senba 2 project. So right in the another project, right now it's called Guangdong 2 project. So in the beginning, like both sides, they bring a lot of lesson learned. We sit down, we actually really listen to other people's their problem, and we want to put our feet into their shoes, and we want to solve this right in the beginning. So this is bring a lot of good advantage to us, and especially into the next project now. Not only that, not only we continue remind each other on all those improvement that we can do, but we're also sharing this experience to our new customer. And then a lot of time we discuss with our customer, our new customer, and say, okay, this is the way that we did in Simba, and then this it works, and then maybe we can try this way. Or this is what we did in Simba, and maybe we can change it a little bit to make it better.
Yeah, I can definitely see how that would benefit all the future projects that you would do together, having that partnership and having experienced the process once together already. So that's certainly a benefit. So, Thomas, what makes the HL class gas turbine technology that was used at Sunba so well suited for Taiwan?
So I think Taiwan has a big content of renewables on the grid. And as we know, these renewables are fluctuating. So as an example, there is a 14 gigawatts of solar installed in the grid. And I think every day, 5 p.m., 6 p.m., if the sun goes down, those gigawatts go quickly off the grid. So this is quite a stretch and a challenge for the grid. So the 9000 HL actually combines a high power density. So we are world record holder in Guinness Books for power output, as well as the highest ramp rate at the same time. So in a nutshell, it means when renewables is going off the grid, this plant with the technology is able to get up to speed with high power output in a very short time. So it's a very good response for the grid operator to serve fluctuated renewables. At the moment, I have to say it is running predominantly on baseload operation. So this technology, as we mentioned earlier, also combines a very high efficiency. So Samba 2 is a IPP project with the highest efficiency under the IPPs currently in Taiwan. So I think it's the flexibility what makes this gas turbine really suitable for Taiwan, independent on what is required, whether it's cycling operation, it's quick startup, or it's baseload operation. So yeah, that's the main features what our technology is bringing here to the country.
Great. And Taiwan is well known as a semiconductor and a high-tech industry country. It supplies a lot of the technology that is used around the world. These industries really rely on consistent power. So, Ewan, from your perspective, what role does the Sunba plant play in supporting those industries and the need for reliable power?
I think Taiwan is currently, like many other countries in the world, is going through energy transition. So we are shutting down the last nuclear unit in Taiwan this year, so nuclear free. And then we are shifting from coal to gas. And all this have to be taken under a short period of time, minimum interruption to the consumers, and then also ramping up renewable. So there's a lot of challenge to do this in a short time. And then, like Thomas had shared, this technology, high power density, can be completed within a reasonably or relatively short period of time. And then this has become a backbone for this Taiwan's industry, especially the semiconductor industry, because in Tainan, in the same, let's say, county as Samba, TSMC is building a new fabrication plant. Yeah, and this development on this site consumes 500 to 800 megawatts. So this is a huge power consumption. So this Samba plant is 1100 megawatts, and it's basically fulfilling this demand and this development of this new semiconductor fabrication plant. And since this plant, Samba brought online, and it has been running baseload. So it's really supplying the much needed power from this semiconductor industry. And this industry is continuously growing in Taiwan.
And we have talked a lot about the efficiency and how important it is with LNG, but Thomas, can you maybe talk about how the economics and even the environmental benefits that are provided by that and get a little bit more insight on why that is so important?
So I think economics, we have said, so efficiency there is the main driver. It also, I think here in Taiwan, capacity is a big driver. When we look at environmental aspects, Samba is running on the lowest benchmark level when it comes to NOx emissions. So we're also setting benchmarks on the emission side. And I think if you look into the future, then there is hydrogen as a buzzword all over the world. So this plant also is generally capable of handling hydrogen. It would need an upgrade, but I can say it's from an environmental perspective and future perspective, we can say it's future proof and possible to handle also other fuels in future.
And Andy, can you talk a little bit about the digital features and the service contract that Siemens Energy has with Sunba 2?
The grid needs this power produced by this power plant. So, in a short summary, we need to keep the power plant on grid as much as possible, and also to do preventive maintenance, right? So we have from Siemens Energy side, we have a lot of tools that we support our customer, to do all this stuff now. So for example, now we have this tool called PDS, Power Diagnostic Service. Basically, it's integrated with our control system T3000. So that it gets the data, from the power plant, and it does its own analysis. And then if something is acting odd or acting strange, now it automatically generates a report and it sends to the customer. For example, like if the bearing vibration today is a little bit higher than yesterday, the system generates this report and send this to the customer that today is a little bit different. Maybe we can take a look for during the next opportunity now. So this we're trying to do this preventive action. In order to keep this power plant online as much as possible and as efficient as possible. That's one tool. So the second tool is we also offer the customer this ROM, remote operation maintenance. Basically, we have a team sitting in Germany 24/7 now. So the customer can contact and also work with us with this team on any of the OEM problem. So if they feel like that there's some setting that could be a little bit adjust, they can contact us. We discuss, and then we can go through all the technical details with them. Yeah, if they feel like they need support on troubleshooting on one of the system, they also contact us, and then we can support them remotely. Because for customers' goal and for our goal is to keep this the power plant as alive as possible.
Yeah, I can see how working together with the client and Siemens Energy to maintain all of the systems at top performance is really important. So it's great to hear. And Ewan, from your perspective, how does Siemens Energy see its role evolving in Taiwan's broader energy strategy, and especially with rising electricity demand that's being driven by AI and data centers? I can see that more of these types of facilities may be needed.
So I see Siemens Energy is growing with this development. So there are two policy or two trends in Taiwan I quickly mentioned. One is coal to gas, and the other one is ramping up the renewables. So for the coal to gas end, I think after Samba, we have one Guoguang 2. It's the same configuration, 2-on-1. Under execution, and we also won another projects, and then so we are continuously growing and developing in this market. And then on the renewable front, so Siemens Energy also has Siemens Gamesa. We have a wind power, especially here in Taiwan. We are focusing on the offshore wind. In Taichung, we have nacelle assembly factory. And then this factory is serving not only the Taiwan market, but also in the region. So Korea, Japan. And so this will be a hub supplying the offshore wind cells for the market. So Siemens Energy is established, and we continue to grow with this boom of electricity demand.
Yeah, it's really an exciting time actually to be involved in the power industry because there's so much going on, so much expansion and development, and it seems like your group is really involved in all aspects. So that's great to hear. So, gentlemen, it's been a real pleasure speaking with you. Again, for listeners, I've been speaking with Thomas Ringman, Director of Business Development, Yuan Chi, the Sales Manager, and Andy Chang, a Project Manager in Taiwan. Gentlemen, is there anything that we haven't talked about that maybe you'd like to bring up before we wrap up the podcast, or any last words that you'd like to share before we go?
Well, I like to share because, as I said, the project is very close to my heart. So the Samba 2 project brought me to Taiwan, and came here during COVID. So I had a lot of struggle at the first time. Then we were fighting together to execute the project. From the sales side, we were supporting as much as we could. So to stand here now and that this project got recognized with your power plant award, I think this is really a nice story and a nice finish I would never have expected when I came here. So thank you very much, Aaron, and magazine and readers for selecting us on this award. So really appreciate and really want to say thank you.
Andy?
Yeah, I also just want to thanks Aaron, the magazine, and also the reader as well. So I've been through this execution, every day, and then I would say it was hard. It was hard every day now, but now as to see this complete and also get awarded, it's also bring a really putting a peace in my heart. So thank you.
Thank you guys for the work that you do and for completing this plan. I think it is really special, and I congratulate you on the award as well. So thanks very much.